Now, having seen the three problems of your classical synchronization, in today's session of your operating system, we move on to the next topic, which is nothing but a monitor. Before we enter into the details of the monitors, let me first explain you what is the basic need of going for a monitor here. Now, we have already seen a semaphore thing where how to enter into a critical section. So, you have a critical section part where all the shared resources or the instructions related to the shared resources are dumped up in this critical section, and at a time only one process can enter into critical section. So, before entering this, we need to go for executing your wait, and after coming out of your critical section or the exit section, we go for performing signal operation. Now, these are user defined. So, user has to write a program in case of a semaphore. So, while writing the program as a human nature, assume I just interchange the order. Instead of writing wait first, I will go for signal and then the wait. So, what happens in this particular case when you are including signal at the first stage? Any number of process can enter into critical section. So, here the main purpose of the critical section will be violated. Why? Because more than one process is in the critical section because of this interchange. Now, we will go for a case where while typing it, instead of typing here signal, I will just go for writing a wait here. So, in that case, what is the problem you get? P1 is in the critical section. Even though it comes out of the critical section, you are not changing this mutex value. So, in that case, P1 will be in the critical section and it will not allow anybody to enter into critical section, and this leads to deadlock. Moving on to the further, before moving on to the further, here mutex stands for your mutual exclusion. You will call it as a mutual exclusion, and a binary semaphore which we have seen in the previous class, binary semaphore, we can even call it as a mutex. So, because of those two problems what we have encountered in the semaphore, we go for using a concept known as monitors. So, here monitor is nothing but a high level programming construct. So, here you will not write the individual instructions. So, it is a high level programming construct, or in other term we call it as an abstract data type. And you all know abstract data type is nothing but you have the data types and the methods predefined, but you are least bothered with the internal representation. Similarly, now we go for using monitors, and in many of the programming languages, so when you go for Java, we have wait and notify which are predefined. I will just use them. So, here also we go for using a monitor. You just declare the name of the monitor and you have your shared variables and any number of procedures and your initialization code. So, these are the three basic parts of the monitor. Now, when you go for this particular procedure, we take care that any point of time only one particular process is executing a procedure. So, multiple processes will not be executing the procedures at the same time. So, when you go for seeing the schematic view of it, so that is your actual monitor. When you go for seeing the schematic view of the monitor, this is your shared data and these are all your procedures and your initialization code. So, when you see this, this is nothing but a queue. What is a queue here? You will allow only one process to enter into the shared procedures or the procedures, whereas all of them will be present in the queue. When this particular process which is using the procedure comes out of this particular monitor procedure, then you allow somebody from the queue to enter into the critical section. Now, in addition to the structure of the monitor what we have seen, we go for using two variables here which we call it as conditional variables x comma y, and on these condition variables we go for performing x dot wait and x dot signal as of your semaphore. So, here x dot wait, what it will do is it will suspend a process if some other process is in the critical section and P2 also wants to enter into the critical section. So, this process will be suspended. And when I go for x dot signal, so all these suspended process will be present in a queue as we have seen in the schematic diagram. So, this x dot signal will take out a process from the queue and allows it to enter into the critical section. So, if P is in the critical section and Q wants to enter, you will suspend this particular process, and again after P completes the performance of the operation, P will resume the operation of the Q. So, it is a responsibility of this process to resume the operation of the other process which is being suspended. So, in that case, we have two possibilities. One is signal and wait. So P has given permission that you enter into critical section. After that, what will P do? When I go for signal and wait, signal, P is giving a signal to Q that you execute, and once till the Q performs the operation, P will be just in the waiting state. Whereas we'll go for the second condition, which is nothing but signal and continue, wherein signal and continue, what will happen is though P is given the signal, P has given the signal to Q that you continue it, P will continue the remaining part of the operation and then the chance will be given to Q. So here P will be continuing and Q will be waiting, whereas here P will be waiting. Now, whatever conditional variables we have seen here, the same thing will be implemented. So X, this is your conditional variable, and these are your X and Y variables associated with your wait and signal. Now, what was the problem when you go for your dining philosopher solution? In the previous case, we have seen if all the philosophers are feeling hungry at the same time and each of them go for grasping the left chopstick and waiting for the other to leave the right chopstick, it is not possible. It was leading to deadlock. So here, what we do in case of monitors is, first we go for declaring the enumerated data types, and these are the different activities a philosopher can do. He can think, he can feel hungry, or he can go for eating when he feels hungry. And this is a state of the philosophers. Why have I taken it as 5 is, we are going for 5 philosophers, P1, P2, P3 and P4. Or you can even initialize them from P0 to P4. Now, we basically have two operations here, pick up and put down. If a philosopher is feeling hungry, he will take up a chopstick, and once he is done with the eating part, he will be putting down that particular chopstick. Now, assume we will go for the just representation of it. It is P0, P1, P2, P3 and P4. These are 5 philosophers who are available. Now, initially state of I is equal to hungry. So, you have a state pertaining to 5 philosophers. This is state 0, 1, 2, 3, 4. And here I am making it as hungry. The philosophers is feeling hungry. Test of I. So, test of 0, it will be going into this particular condition. Now, you check test of I plus 1. I plus 1 here is nothing but 0 plus 4. 0 plus 4 is nothing but 4 percentile 5. So, this is P4. Assume this particular philosopher is not eating. So, this is true. And state of I means the current philosopher is hungry. Yes, it is true. And state of I plus 1. I plus 1 is nothing but 0 plus 1, which is 1. 1 percentile 5 is equal to 1. And this state is also not eating. So, what you are doing here? Well, a P0 is feeling hungry. You are checking the state of the adjacent philosophers, whether they are feeling hungry. So, in this case, both of them are not feeling hungry. Then, the state of I, which was hungry till now, will be now updated to eating. State of I is eating. And you are giving a signal to yourself that you can enter into critical section. So, from here we have jumped into this. So, we will go back to the next statement. State of I. If state of I is not equal to eating, but in this case it is equal to eating. So, you can continue with your procedure. And once you have done with the eating, you will be going for which state? You go for thinking. So, from hungry you entered into eating. From eating you will go on to thinking, because these are the 3 activities. And you just perform the test on I plus 4. So, you check whether P4 is hungry or P1 is hungry. You perform the same test once again. So, before P0 is picking up the sticks, he is checking whether he is eating or he is eating. If nobody is eating, both the chopsticks are free, then he grabs the chopsticks and continues. So, deadlock problem we can overcome, but sometimes you may end up with the starvation problem in this particular case. Now, when you go for this monitor concept, you already know what is a semaphore here. We go for implementing wait as well as signal operation. The same thing we are implementing using your monitors. So, this is your mutex value, which will be initially 1, and this is your signal. And here when you go for this if S count of 0 greater than 0, it means that it is related to your suspended process. The number of process which are being suspended. So, if the count is greater than 0 means that more number of process are being suspended. You give a signal to this after you finish your critical section. Otherwise, what you will do? You will just go for signaling of your mutex. So, this is a semaphore value related to the process which are being suspended. This is a normal lock. Mutex you already know. So this is a normal rock related to entering into the critical section. Now, the same conditional variables whatever we have seen, x dot weight and x dot signal. What will x dot signal do normally? It will suspend a process. So this is for suspending a process, and this is for invoking a process, or you start up a process or wake a process. You wake up a particular process. Now if your s dot count of 0, so you are just checking it. If the signal of your x number, you can check which particular number of processes that are being present here, and you go for including your weight of s. And since you are waking up a process, the count of your normal queue will be decremented by -1. So if initially if a queue contains 5 processes and out of which you are removing 1 process from the queue, the count value will be decremented by -1. Whereas this is for suspending a process. So when you want to suspend a process, this is your queue, you go on adding the process into the queue because you don't want to make them enter into critical section. So here the count value will be incremented. So you go for incrementing here, whereas here you go for decrementing the same value. So this implies that monitor is nothing but a programming, high level programming structure where you have a predefined functionalities and you have to use it. So there will not be any typographical errors as we have encountered in the semaphores. We move on to the next topics in the next class.